Welcome back to a new series of videos. In this lesson in geometry, this unit that we're going to be talking about, we're going to be talking a lot about coordinate geometry, which means we're going to be talking about these geometric concepts that really aren't all that new, but we are going to be looking at how they are represented in the coordinate plane, as in the XY coordinate plane. Okay, so I want you to remember when we talk about coordinate geometry, this vertical axis is called the y-axis, this horizontal axis is called the x-axis, and they intersect at the origin, 0, 0. And so those are going to be important pieces. Any ordered pair for a point, any location on this graph is given to us as a point with coordinates x, comma, y. Okay, where it lines up with the x-axis and then where it lines up with the y-axis. We have quadrants where everything's positive. This is quadrant 1. And then when x is negative, sorry, that's positive, positive. This is negative, positive. Down here in quadrant 3 now, that was 1, this is 2, this is quadrant 3. That's negative, negative. And then lastly in quadrant 4, we have positive x's but negative y's. Okay, so that's how ordered pairs line up in the coordinate plane. So we're going to use some of that information. There were some formulas that we've used earlier in the year that we need to remember. Formulas for distance, midpoint, and slope. And we're going to identify what those are, and so I want you to copy these down. Okay, for our distance formula, it's the square root of the difference of the x-coordinates squared plus the difference of the y-coordinates squared. For our midpoint formula, we're just taking the average x-coordinate and the average y-coordinate, add up the x's, divide by 2, add up the y's, divide by 2. And for slope, on this one, you'll notice we have our difference of y's and x's, but it's the difference of the y's over the difference of the x's. We talk about slope also as rise over run. Okay? And while we're talking about slope, there are some specific types of slopes we can have. Every slope is going to fall into one of these categories. Okay, if our line is going up and to the right, or when you do your formula, you would get a positive slope. Okay, if it's going down and to the right on a graph, you would have to have a negative slope. But then we have two special cases, all right? If we have an exactly horizontal line, no rise at all, just run, we call that a zero slope. But if we have a completely vertical line, straight up and down, so all rise but no run, left and right, we call that an undefined slope. And when I plug into this formula, to get this, the bottom of your fraction would have to be 0, okay, where we have some number divided by 0. That gives us an undefined slope because that's not possible mathematically. You can't divide by 0. Okay, so what we're going to do now, we're going to do some examples where I give you two ordered pairs to represent points A and B on a graph. You'll notice in this lesson we're not actually doing any graphing. We're just using the formulas. And in this case, we're going to use these three formulas to find the slopes of the lines with these points on those lines. So I'm going to do one with you. If A is at 3, negative 2, and B is at negative 5, 1, this is your first x-coordinate, this is your first y-coordinate. This would be your second x-coordinate, this is your second y-coordinate. So that means when I plug in to my midpoint formula, I'm going to add the x's, 3 plus negative 5, or negative 5 plus 3, it doesn't really matter the order. But if I add it in this order, 3 plus negative 5, it becomes 3 minus 5 over 2. Then I'm going to add the y's. Okay, negative 2 plus 1, all over 2. And to simplify this, 3 minus 5 is negative 2. Negative 2 divided by 2 is negative 1. Negative 2 plus 1 is negative 1 over 2, leaves us with a negative 1/2 fraction. Or you could write it with a decimal. Okay? For the length, to calculate the length, we're going to use our distance formula. We're going to subtract the x's. Excuse me. we're going to do 3 minus negative 5, or if you want to stick with x2 minus x1, you would actually start with negative 5 minus 3 squared, plus 1 minus negative 2, which we changed to 1 plus 2, so we don't have that double negative. And then we start to simplify this. Now you can put this in your graphing calculator all at once, and it would look a little like this. Okay, we want the square root, so I hit second square root, and it brings up a parentheses for my square root. And I'm going to open another parentheses for this first parentheses squared, negative 5 minus 3 parentheses squared, plus parentheses for this one, 1 plus 2 parentheses squared, and then you want to close your parentheses for your square root. And we should get a distance of approximately 8.5. That's how far apart those two points A and B are. Okay, so that'd be the length of that segment AB, which is the distance. Notice length, we use distance formula. And now we want to find the slope of the line passing through using our slope formula. So we're going to do our difference of our y values. Okay, I can still enter it like this. 1 minus negative 2 becomes 1 plus 2. And the difference of the x values. That'd be negative 5 minus 3. Well, 1 plus 2 is 3. Negative 5 minus 3 is negative 8. So we leave this as the negative fraction, negative 3/8. We don't write it as a decimal, we don't divide it out, we write it as our fraction, as our slope, rise over run. This would have a negative slope because it means I would go down 3 to the right 8 if I were to graph it. Okay. If you can't see that, that's okay. You don't have to. So what I want us to do now, I want you to do the next couple of these on your own. I want you to pause the video. I want you to find your midpoint, length, and slope for the next two. And then when you're ready to check your answers, you can click play. If you need any more time, go ahead and keep the video paused or pause it again. These are the answers you should get. Okay, for this first one, you get a midpoint of 3, 9, and then you get a distance of exactly 2. And the reason that is both of these ordered pairs share the same y value. This, on a graph, would be a horizontal line. And so I only have to calculate the distance horizontally, which would be 2. 4 and 2 are just 2 apart. But in the distance formula, it does work out that way. And that means since it's horizontal, when I plug into my slope formula, I get 0 over 2. 0 divided by anything is 0. So this has a slope of 0. Okay, for the next one, we have a midpoint of 3, 3, a distance of 10.8. It's like 10.77, I think. And then our slope is, again, negative 2/5. If you wrote your answer as negative 4/10, that would not be counted correct because we always want to reduce our fraction as far as we can. So we're going to take a look at this next one in class, all right? So if you've done these 3 rows, that's fine. We'll take a look at the next row in class. So as we continue along, we do want to take a look at linear equations on a graph. And they have 2 very specific forms that we're going to use in our lessons. Okay, the first form is what we call Slope-Intercept Form, which a lot of you will remember. And that's y equals mx plus b. Where that's your slope, that's your y-intercept. M is your slope, b is the y-intercept. That means where the line ends up crossing the y-axis. Okay, the y-intercept we find by setting x equal to 0 usually. All right, and then we also have something called standard form. Standard form looks a little bit different. That's where the x and y are on both the same side of the equation. You'll have a number in front of x plus a number in front of y equals some other number c, and these are all integers. Usually we make sure a is a positive integer, meaning no fractions or decimals. And so it's really difficult to look at what slope is in this form. But what we are going to be, what we're going to be doing with any equation in this form is transforming it into this form to identify slope. All right? And so we want to find the slopes of these given lines. So in this example, we really just, if it's already in slope-intercept form, the slope is given to us. That's just a slope of 2/3. So if I'm going to identify the slopes, it helps if it's in that form. Here my slope is negative 2/3. Okay? But in line C and line D, we have to put them into slope-intercept form first. And so that's where we are going to require you to do a little bit more work. To get this form into slope-intercept form, you'll notice y is by itself. All I really have to do is solve for y, meaning get y by itself. So the first thing I'm going to do here is subtract 2x from both sides. That leaves me with 3y equals, I'm just going to write the negative 2x in front plus 15 because I cannot combine these. They're not like terms. Y is almost by itself. I still want to get rid of the 3. So we divide by 3 everywhere, which gives us this new equation. Y equals negative 2/3 x. I want to leave that written as a fraction. And then 15 divided by 3 turns into 5. So this has a slope. Okay, your slope is negative 2/3. Okay, let's do that again. On this next one, we want to get y by itself. So we first subtract 6x from both sides, giving me 4y equals negative 6x plus 24. Then divide everything by this 4. And so we get y equals negative 6 over 4 becomes negative 3 over 2 when I reduce it. I can divide both of those by 2. And then 24 divided by 4 is 6. So this has a slope of negative 3/2, or negative 1.5 if you wrote it as a mixed number. When we look at multiple lines and we compare their slopes, that is enough to tell us the relationships of those lines. Okay? So on a graph, if two lines are parallel, they have the same slope and different y-intercepts. Okay? Same slope, different y-intercepts. So they have to be in slope-intercept form to identify that. If two lines are perpendicular, now let's go back. Parallel means they don't intersect. Okay, parallel lines. Perpendicular means they do intersect, but exactly at a 90-degree angle. Well, again, their slopes are going to tell us that. All right. We are going to say that these slopes of the perpendicular lines are opposite, I'll write it out, reciprocals. And I'll give you an example. Okay, if one slope equals 2/3, the other slope would equal negative 3 over 2. Opposite, we go from positive to negative or negative to positive. Reciprocal means we flip the fraction. So these are opposite reciprocals. And it really doesn't matter what their y-intercepts are. If they have opposite reciprocal slopes, we know they are perpendicular. And then we also have the option that neither of these is true, and that just means that they are intersecting lines. Okay? Neither means that they are intersecting lines, which means that they just have different slopes. All right, again, it doesn't matter what their y-intercepts are. If they have different slopes that are not opposite reciprocal, okay, just different and not related, then they are neither parallel nor perpendicular. So in our next example here, we're going to take a look. We're going to use the slopes from line A, B, C, and D from the previous example. And we are going to find two lines that are parallel, two lines that are perpendicular, and two lines that intersect at a non-right angle. That's my neither option. All right, so in these first two, we have a slope of 2/3 and a slope of negative 2/3. Those aren't the same. They're exact opposites, but they're not opposite reciprocals. Okay, we have 2/3 showing up again in line C. Okay, so line A is parallel to line C because they have the same slopes. I'm sorry, let me take that back. line B is parallel to line C because they have negative 2/3 slopes. Just about steered you down the wrong path, sorry. So there's my parallel. Okay, the perpendicular lines I'm looking for have to have a slope of negative 3/2 and positive 2/3, just like the example I gave, because these are opposite reciprocals of each other. So I would say line D and line A are perpendicular. So A is perpendicular to D. Perpendicular. And then we want a neither option, where they just have different slopes that are not opposite reciprocals. Well, that was that first two I looked at. Line A and B have different slopes that are not opposite reciprocals. So line A and line B. Now, I could also have used line B and line D, because they have reciprocal slopes but not opposites. All right? So either of those pairs would be a neither example. They intersect at a non-right angle. All right, for the sake of time in this video, we're going to wait to finish the rest of these examples until you are back in class. So we will pick up here when you return to class, but hopefully you've gotten a basic understanding of the concepts we're covering, and we should be able to finish up the lesson together.